Okay, so this video will go with problems number 1 and number 5, I believe, on the worksheet. And so the first thing is, it says each of the following statements describes, it should say, an intermolecular force, where each of the statements indicate if it describes London forces. So what we call them in class is London dispersion forces. Okay, dipole, dipole, so DD is dipole, dipole, or hydrogen bonding. Okay, so something that occurs in all molecules are London dispersion forces. Okay, the strongest type of these three is hydrogen bonding. All right, now if ionic was on there, ionic would be stronger, but it's not on there. Okay, occurs in polar molecules. Well, remember, London dispersion forces are in everything, but if it's a polar molecule, you also have dipole, dipole. And in certain ones, you can have hydrogen bonding, but we'll just skip that for now. Okay, occurs when a temporary dipole occurs. So that's like London dispersion forces. That's like when, like for an example, if you have hydrogen is H2 and the electrons are here, well, these electrons can move around. The electrons are moving, all right? And so at any given point in time, here's hydrogen like a later point in time. In a later point in time, the electrons could be closer to one side of the molecule compared to the other, and when in the shared orbital. So the side that they're closer to, that would make that side of the molecule negative, and that would make this side of the molecule positive. Okay, because the electrons are moving. It creates a temporary dipole, but it only lasts for a fraction of a second. Okay, strength depends on the number of electrons in the molecule. Okay, that's also London dispersion forces. So one thing you need to remember, more electrons equals greater London dispersion forces. All right, occurs in molecules where hydrogen is present. Well, London dispersion forces are in everything. Okay, but also you can, in certain cases, have hydrogen bonding. The key is to identify hydrogen bonding. Hydrogen has to be bonded to either F, O, or N, and I like to say hydrogen has to be sandwiched. You have to have a hydrogen sandwich between F, O, or N. For example, if you had hydrogen fluoride, and it could have a force of attraction with another hydrogen fluoride. And anyway, this force of attraction right here would be called a hydrogen bond because this hydrogen is sandwiched in between two fluorines. And I didn't draw the lone pairs, but the fluorine should have lone pairs on it. But anyway, okay, so this would be a hydrogen bond right here. Okay, if you had something like this right here, like let's say you had hydrogen bromide, HBr, and so here's HBr, and let's say it was attracted to another HBr. Okay, now this would not be an example of hydrogen bonding because there's no hydrogen sandwiched between F, O, or N. Okay, so no hydrogen bonding. This one would just be dipole, dipole. Okay, is affected by the shape of the molecule. Well, basically what that is getting at is if a molecule is polar, it has dipole, dipole for sure. Okay, the next question is question number 5. You have to rank them from the strongest to the weakest. Well, ionic bonding is number 1. It's the strongest. Okay, then followed by hydrogen bonding, then dipole, dipole, and then London dispersion forces. Okay, that's the order that they go from the strongest type of force to the weakest type of force. Okay, that's it for this video. You'll have to see the other videos to get the other questions in this document here.